going to operate with functions, which means we're going to use them, manipulate them, and whatnot. So more multiplying functions here. The warm-up had a binomial times a binomial. I will use those terms. If you do not know what I mean by that, we have a problem, okay? Think bicycle, 2 wheels, right? So binomial means 2 terms. We have a binomial right here to start with. X and 3, 2 terms. That's a binomial. This is a trinomial, 3 terms. X squared plus 3x plus 9. So we're looking at a binomial times a trinomial. The process is the same. We just have an extra term that we have to distribute to. Now, some of you may prefer to arrange this in kind of a box-like method, and that is fine if that's how you like to organize it. Me personally, I just look at it like this. I distribute the first term to everything in the second set of parentheses. So x times x squared is x cubed. X times 3x is 3x squared. X times 9 is 9x. And then I distribute the second term to everything in the second set of parentheses. So distributing the negative 3, negative 3x squared, negative 9x, negative 27. If this is what you like to do, this is fine. If you want to set up a little box like this, and you just multiply everything and put the result in the box, that's fine. If that's how you want to organize it, go for it. That's just not my thing, okay? All right, combining like terms. I always start with the highest exponent first. It keeps things organized, and it keeps me from mixing things up. So x cubed. Then I go to the x squared. We have a positive 3x squared and a negative 3x squared. Those cancel. We've got a positive 9x, we've got a negative 9x. Those cancel. So this simplifies down to x cubed minus 27. Now, will it always become that simple? No. Okay. But in this case, this one was set up in a special way. This one does reduce down to just 2 single terms here. Questions? All right. What do we do when we see something like b here? 3b minus 2 in parentheses and it's squared. Do we just square those 2 terms? Yes? No? Right, we have to take the same thing twice. Remember what it means to square something. You multiply it by itself. By itself. You have to write it twice. You multiply it by itself, and now it becomes a double distribution problem, or a FOIL, or a box, whatever you want to refer to it. That's what you do. So this is going to equal 9b squared. The outside 3b times negative 2 is negative 6b. Negative 2 times 3b is negative 6b. Negative 2 times negative 2 is positive 4. Bless you. You're welcome. And then combine these terms in the middle. Negative 6b minus 6b is negative 12b. It's not 0. They don't cancel. They don't have opposite signs. Negative 6 plus negative 6 is negative 12. Okay, so that is not 9b squared plus 4. You miss that middle term if you don't write it twice and multiply. So similarly, if we've got a situation like this, 2m plus 5 cubed, what do you think we need to do? Write it down 3 times. Okay, write it down 3 times. Now, here, there are a couple of different ways that you can handle it. The way I like to do it is I multiply the last 2 binomials together first. I'm going to keep that 2m plus 5 here in the front, and I'm going to multiply 2m plus 5 times 2m plus 5. Or m squared. Are you okay with me going ahead and combining the outside and the inside? We got 10m plus 10m So we have 20m. If you need to take an extra step for that, that's fine. And now we're back in an example like A, binomial times trinomial. So distribute that 2m to everything. 2m times 4m squared, 8m cubed. 2m times 20m, 40m squared. 2m times 25, 50m. Distribute 5. 5 times 4m is 20m squared. 5 times 20m is 100m. And 5 times 25 is 125. Last step, combine some like terms. 8m cubed, only cubed term. 40m squared, 20m squared, so we've got 60m squared. 50m, 100m, so we have 150 m's, and then the constant 125. All right. Any questions? Those can get a little lengthy. I'm not going to ask you to go above cubing it. Okay? I'm not going to ask you to go above cubing it. Now, you could continue this pattern. You could raise something to the fourth, but you can see how it's going to get big, right? All right, so that's what I wanted to go over with multiplying. Let's look at some dividing. Let's look at dividing some functions here. Yeah, we will look at dividing more later, but we're going to start with just the simple basic dividing by a monomial, a single term, dividing a polynomial by monomial, and many terms by one term. And all you do is divide each term by that monomial. So I like to do this. If I'm writing it down on my paper, I do this so I don't forget anything and so I can see it better. I just go through and I put what I'm dividing by underneath each term, and then it's just a matter of simplifying. Okay, 9 over 3 reduces to 3. Exponent rules, what do you do with exponents when you're dividing? Subtract. Okay, think of that division line like a subtraction line. So x cubed over x is x squared. Negative 12 divided by 3 is negative 4. X squared over x is x. 6 over 3 is 2. X over x simplifies or reduces to 1, so it's gone. And then that last one, 7, does not evenly divide by 3, nor does it reduce. So we just leave it as it is. There was not another variable to simplify with, so we just leave that x down there in that denominator. Okay? That's how we would leave that answer right there. Do another one like that. This time we're dividing by 4x squared. It's a little bit higher powered. It's still a monomial, one single term. It just has a higher degree. So again, go through, put your divisor, what you're dividing by. Under each term, so we can just look at each one individually and analyze it. Negative 16 over 4 reduces to negative 4. X to the fourth over x squared reduces to x squared. 4 over 4 reduces to 1. X squared over x squared reduces to 1, so we've just got plus 1 there. 5 over 4 does not reduce. We've got x squared in the denominator, x on the top, so that leaves us with x in the denominator. 18 over 4, they're both divisible by 2, so that reduces to 9 over 2. And we didn't have a variable other than that x squared, so we leave the x squared in the bottom. Yes, sir?
5 over 4x, right?
Okay, why did I not put the variable in the numerator? Because it was bigger, the degree is bigger in the denominator. So anytime I'm dealing with variables and exponents, when you subtract 2 minus 1, you put it where the bigger exponent was. So the bigger exponent was in the denominator. So that x goes in the denominator. All right, any other questions? Technically, this would be the standard form here, even though our constant is kind of stuck in the middle. But these exponents, if we were to put them in the numerator, would be negative exponents. So you are going in decreasing order. Highest power squared, 0 degree, that would be -1, that would be -2. So you are decreasing there, even though it looks kind of weird to have that constant in the middle. That would be the standard form. All right? Any other questions about the dividing? Pretty simple. I just need to show it to you. Let's look at one more thing. Now, this is probably completely new. This is called the composition of functions. The composition of functions. So you may hear it called, we're going to compose f with g or g with f. What you're going to do is you are plugging one function into another function. That's what the composition of functions means. It means you're plugging one function into another function. So let's look at this example. We've got f of x is x squared plus 3x minus 1. G of x is 3x plus 2. So let's think about this for a second. If I asked you, what is f of 3? How would you find that answer? If I asked you what is f of 3, how would you find it? You plug in 3 into f, okay? Well, essentially, that's what I'm asking you right here. What is f of g of x? So instead of having a number, I've got an expression there. So this may help you out to replace g of x with its expression. Okay, that is g of x right there. G of x is equal to 3x plus 2. So I replace it with its expression. Now I'm going to plug its expression into f, just like I would if it were a number. So if it were a number, I'm replacing the x's with the number, in this case, the expression. So it's the expression squared, just like it would be 3 squared. And it's 3 times the expression, just like it would be 3 times 3. And then that minus 1, I mean, that's what I would do before. I would just subtract 1 from what I've got so far. Now, we do need to do some simplifying here. Okay, we need to expand or multiply out the 3x plus 2 squared. Now, if you want to write it out before you multiply it out, that's fine. I'm just going to go ahead and jump to that's equal to 9x squared plus 12x plus 4, because the outside and the inside both give me 6x, so I get 12x there in the middle. And then we distribute the 3, so plus 9x plus 6, and then we still have that minus 1 there on the end. And then we just combine our like terms. 9x squared plus 21x plus 9. 4 plus 6 is 10. 10 minus 1 is 9. Okay. So that's f of g of x. We plugged g of x into the f of x function, and we simplified it. Now, do you think the order matters? Do you think that g of f of x will give us the same answer? And I see some people saying yes, I see some people saying no. Let's find out. This is also notation for the composition of functions. You don't see it as much, but it is the same thing. I prefer, if I see that, I automatically go ahead and write it the other way. Okay, you got to keep the order the same. So G came first, but these two notations right here are the same notations. All right, so just be aware of that. If you see a little circle, not a dot means multiply. If you see a little circle, that means to compose. All right, so let's see if the order matters. Let's find G of f of x. All right, so f of x was this function, x squared plus 3x minus 1, and we're plugging that into G. So everywhere we see a variable in G, we replace it with that expression, just like we would plug in a number. We're just plugging in an expression instead of plugging in a number. So do we still think that it's going to be the same thing? No. Okay. In this case, all we have to do is distribute that 3x squared plus 9x minus 3 plus 2, and then add our constants at the end. 3x squared plus 9x minus 1. Okay, so the order of composing functions matters. It matters which function you're plugging into. You get two, I mean, they're similar. They're both quadratics, but they're fairly different quadratics there. Okay, so order matters. Order matters. Let's do another one. Let's use a square root function for one of them this time. So our first function, our g of x, is the square root of x minus 4. Our second function, h of x, is 3x squared minus 5x. So let's start with g of h of x. G of h of x. Again, I don't like that notation. I'm going to automatically change it when I write it down. But I keep the order. G came first. So h of x is 3x squared minus 5x. I'm going to take that expression and I'm going to plug it into the g function, and I'm going to replace that x with that expression. 3x squared minus 5x minus 4. That's all we can do with that function. We can't simplify that. There are no terms to combine. It's under a square root. We can't take the square root of those individual terms because they're separated by pluses and minuses. So that's it. That's g of h of x. Now, how about h of g of x? Let's go the other way. G of x is the square root of x minus 4. We are plugging that into h. So h was 3 times x. Well, x is now the square root of x minus 4 squared minus 5 times x, which is now the square root of x minus 4. Okay, now, what happens when we square a square root? It cancels. Square roots and squares are inverses. They're opposites of each other, so they cancel. So that just becomes 3 times x minus 4. Now, that only worked because this entire thing was under a square root. Okay, if it had just been the x that was under the square root, so if it had just over here to the side, this is not the problem, but I wanted to bring this up. If it was that, we would have to FOIL that out. Okay, well, slightly different case because see, this is more than one term. This is one term because everything's under the square root. This is more than one term because there's a minus in between the square root of x and the 4. Okay, 2 different scenarios there. All right, nothing we can do with that last one except just not put the parentheses there. You can't multiply square roots unless you're multiplying it by another square root. So we can distribute the 3, and that is it. You cannot, remember back to the absolute values, you can't put that negative 12 and that 5 together, because that 5 is being multiplied by that square root. Multiplication comes before addition and subtraction. So that is it. Do not combine those two numbers right there. That's as far as you can go. All right. Questions? Seem okay?